Limiting reactant and theoretical yield calculations allow us to work out the maximum amount of product that we can make given a certain amount of reactants. So here we have the balanced chemical equation for the formation of ammonia, which tells us that 1 mole of nitrogen and 3 moles of hydrogen makes 2 moles of ammonia. Now, if we have 30.2 grams of nitrogen and 3.13 grams of hydrogen, how much ammonia can we make? The maximum amount that we can make is called the theoretical yield, and the reactant that limits us to that amount is called the limiting reactant. So let's try one of those problems. Now remember, the way we do it is we do a separate calculation for each reactant. So we do a calculation using up all of the nitrogen, and while we're doing that, we ignore the hydrogen. Then we do a calculation using all of the hydrogen, and while we're doing it, we ignore the nitrogen. Okay, so we've been given 30.2 grams of nitrogen. It's a mass-to-mass stoichiometry problem, so we go from grams of nitrogen to moles of nitrogen to moles of ammonia, because we're seeing how much ammonia we can make, to grams of ammonia. Okay, so grams to moles to grams. Grams to moles of nitrogen, we need the molar mass of nitrogen. Nitrogen is 14.01 grams per mole, and it's N2. So 14.01 times 2 is 28.02. We want grams on the bottom. So 1 mole over 28.02 grams. Moles of nitrogen to moles of ammonia, it's a 1 to 2 relationship. 1 mole of nitrogen gives us 2 moles of ammonia. So we want nitrogen on the bottom. And then moles of ammonia to grams of ammonia, we need the molar mass of ammonia. 14.01 plus 3 times 1.01 is 17.04 grams per mole. And that's of ammonia. That's nitrogen. Okay, so we can just plug that in. 30.2 grams of nitrogen. Grams of nitrogen cancel, and we're left with moles of nitrogen. And then convert to moles of ammonia using the molar ratio from the equation. So moles of nitrogen cancel, and you're left with moles of ammonia. And then moles to grams using the molar mass. So moles of ammonia cancel, and you're left with grams of ammonia. Okay, before we put that into our calculator, let's set up the next one. So this time we've got 3.13 grams of hydrogen. So we're going to go from grams of hydrogen to moles of hydrogen to moles of ammonia to grams of ammonia. Grams to moles, we need the molar mass. So 2 times 1.01 is 2.02 grams. We want grams on the bottom. Oops. And then moles of hydrogen to moles of ammonia, that's a 3 to 2 relationship. Whoops, 3 to 2 from our equation. Okay, so we want hydrogen on the bottom, so 2 moles of ammonia on the top per 3 moles of hydrogen on the bottom. And then moles of ammonia to grams of ammonia, we need the molar mass of ammonia. We calculated that in the previous step, so we already have that. Saves us some work, doesn't it? Okay, so now we can plug in our next number. So we get 3.13 grams of hydrogen, convert it to moles, convert moles of hydrogen to moles of ammonia, and then grams of ammonia using the molar mass. Okay, so grams of hydrogen cancel, moles of hydrogen cancel, moles of ammonia cancel, and we're left with grams of ammonia. So let's have a look and see what we get when we do those two calculations. I'm going to start with nitrogen first. So 30.2 divided by 28.02 multiplied by 2 over 1 multiplied by 17.04. So to 3 sig figs we get 36.7 grams of ammonia as our first answer. Okay, now we're going to do the second one. 3.13 divided by 2.02 multiplied by 2 divided by 3 multiplied by 17.04. 17.6 grams. Just going to check that because I had some calculator issues there. By 2 divided by 3 multiplied by 17.04. Yes, that looks good. Okay, so we have two possible yields. We could either make 36.7 grams of ammonia if we used up all of our nitrogen, or 17.6 grams of ammonia if we use up all of our hydrogen. So the maximum amount of ammonia we can make, given those two amounts of reactants, is 17.6 grams. Okay, even though that's the smaller of the two numbers, it's the amount we can make because we don't have enough hydrogen to make 36.7 grams. We only have enough hydrogen to make 17.6 grams. So that is our theoretical yield. Okay, our theoretical yield is determined by the reactant that limits us to this amount, and that is called the limiting reactant. Okay. So in this case, the hydrogen is limiting us to our theoretical yield. So the hydrogen is the limiting reactant. Now, your limiting reactant will be completely consumed if you make your theoretical yield, right? If you make 17.6 grams of ammonia, you will have used up 3.13 grams of hydrogen. So there will be no hydrogen left. You will, however, have some nitrogen left at the end because you had enough nitrogen to make 36.7 grams of ammonia and you're only making 17.6. So that means that your nitrogen will be left at the end. And so we call the nitrogen the excess reactant. Okay, so we'll have some nitrogen left, you'll have no hydrogen left, and you will make 17.6 grams, which is your theoretical yield. Now we do have one more calculation we can do, and that is the percent yield. So percent yield is your actual yield, that's how much you actually make, divided by your theoretical yield, which is how much you calculate you can make, multiplied by 100, right? Percentages are always parts divided by whole multiplied by 100. So your actual yield can't be calculated, you're going to measure it. So let's say we make 16.5 grams of ammonia. Our theoretical yield was 17.6 grams. Okay, so parts divided by whole multiplied by 100 will give us our percent yield. Let's see what it is. 16.5 divided by 17.6 multiplied by 100, that is 93.8% to 3 sig figs, which is a pretty good yield. We'd be pretty happy with that.